Hello! Today we're looking at the MazeSolver class. This one was a lot of fun to figure out. First was deciding how I would read the file and what I would do with the contents. The first big step, have the 2D array. The second big step, what I call translate a maze row. This method, it takes a line from the file and its row number, and it goes through and it transcribes each number sign into a 1 and just an empty space. Those get turned into zeros. The other big portion, of course, other than reading the files, would be actually traversing the maze to see if any valid exits exist. So here's the PathFinder. This is the one that searches the mazes, and it uses recursion in its hasPath method. And I tried to make these enums to hold the directions left, right, up, down, and these are not directions of where the PathFinder will go. These are actually directions for where PathFinder has been. Here's the method for copying the maze over, which maze copy plays a pivotal role. So here we've got hasPath, it returns a boolean. The PathFinder will use this function to give itself the row and column where it currently is. It tests to see if this is an open space it has found. It will compare its position to the exit row and column, the exit position it's looking for, to see if it has found it yet. And it uses the direction of its previous location, where it came from, to determine where it needs to look next. This way it's not just constantly looking in all 4 directions at every spot. We make a copy of the original maze, and then we have our base cases. If PathFinder was given this opening, for example, the first thing it does before it even calls itself, it'll just look down here. Is this open or not? If it is open, it says we've got a chance that we've got a nice exit here. And so then it starts from the beginning, and it works its way to see if there was a path that led to that exit. If it was given this exit on this maze I made, for example, it would know right away there's nowhere to go. Same thing with this exit, it would just stop itself and return false. But if it has reached the exit, it could only have reached the exit if the path has existed to lead it there. So it returns true. Otherwise, if its current position ventured off to the side margins and it's out of the index bounds, then it returns false to tell itself, oh, don't check here. So this is where maze copy comes into play. Everywhere the PathFinder goes, it'll flip a tile of the previous spot that the PathFinder was. Once it's flipped, it's flipped. You can't flip the maze you're looking at with the way I've set up my PathFinder, but you can flip a copy. So if it returns false, that's not saying, oh, this path is bad. It's just saying, you don't need to check here because we've already reached that point previously, so you can keep looking. If we came from above, then call yourself and look to the left, look to the right, and look below you. And if it came from the left, then it's going to look further to the right, or down or up. If it came from the right, it's gonna look left, down, or up, and then if it came from below, it could continue going up or look to either side. And it increments its row or column to the next space in each direction that it needs to look. MazeSolver will find an exit. That's when it calls hasPath from its PathFinder to see if a path exists from the exit it has found to the entry point, or from the entry point to the exit it has found. It'll basically work its way through the maze by calling hasPath over and over again within itself. If it returns true at the end, it can only do that when it has gone through and reached a valid exit point. That covers the big points. Some interesting bugs I ran into. Reading the file, I decided to make a pull dimensions function. This parameter, first line, it is literally the first line of the file it was given, because the first line contains the dimensions of the maze. Initially, tried to take the first character in the line, and then I took the second integer in that line, and that worked fine for maze A, B, C, K if it goes down that far. But suddenly for mazes like this one, Z that I made, there was an issue. I gave myself this exception that I would catch because I didn't know if there would be cases where we weren't given the dimensions. This error message popped up, and so I knew, okay, it's not pulling the dimension. These are all double-digit dimensions. So instead, I split the first line, and then I parsed the integers. And another issue, my recursive PathFinder method has path was infinicursion on itself. Infinicursion. And that's actually when I decided, okay, I should mark in some way the previous spots that PathFinder has been. I also ran into an issue with that. In the end, I learned there's a difference between shallow and deep copies. And then after I fixed that, then happily ever after, the PathFinder found its way through the twisting, troubled maze. Hello! Welcome to the amazing MazeSolver. Please enter the file name. Okay. Oops, check the file name and try again. Okay. I guess we should start with maze A. Prepare to be amazed. Here it prints out the maze, and it has found one exit. Have an amazing day. Maze B. This one's unsolvable. You can't trick the PathFinder. All 4 exits correctly found. And here we go for the terrible 2, as I call them. 6 exits! When I was running into issues, it was actually finding 10. The good boy that helped save the day, Maze Z, is unsolvable. If I had the time to go back and change anything, I think I would clean up my hashpath method. Some of these checks might be able to be done before it calls PathFinder. I think I could have condensed this into just a few calls to self instead of having this multi-selection line. Now that is it for me. Thank you for watching. Have an amazing day.